Thank you. Any question?
Raj, in literature review, actually, you study one paper of Dr. Shahid, you know?
Yes,
in
sir.
this paper, basically, they are using stochastic fractal search.
Yes, sir.
You know what is this?
Stochastic fractal search is, sir, by taking the equal weights, it's the iterative process through which we can have the fractal, basically, the fractal structure. As we go in deep, the similar structure we are getting. Right? So for finding the similar structure in the iterative process, we use the fractals, and that paper is about the stochastic nature of the fractal search.
In the simple way, actually, I want to know what are the drawbacks of stochastic fractal search.
Oh no, sir, I am not I don't know about in depth about the stochastic fractal search. I just read briefly about it.
Okay, you compare your result with ABC and IWO, no?
Yes, sir.
What is ABC?
ABC is the algorithm that we have, artificial bee colony algorithm that we have, and
Artificial
bee colony.
Artificial bee colony. This
Yes,
is
sir.
correct.
Yes. Let me check, sir. As per my knowledge, it is correct.
So you compare your result with ABC and IWO, no? IWO. What is IWO?
Invasive weed optimization algorithm.
Okay. So you implemented in which platform?
MATLAB.
MATLAB.
Yes.
Please go to your result now. Result graph. Okay. So you mentioned here is this is execution time, na?
Yeah, on the right hand side is the execution time, and on left hand side we have the efficient front.
Okay, so what is the unit of execution time?
Milliseconds, sir.
Milliseconds. Right.
This is for the best run.
Okay, any questions from other sides? Na? Please.
Yes, I have one question. Hello, can you hear me?
Any other queries?
Similar population, right? Within the similar population, we modify the environment, and we utilize two different scenarios where in one environment we have the portfolios, and in another environment we have the weights. Right?
So over from my side.
Sir, I would like to ask you some questions now.
Sure, sir.
I would like to ask you the first question, that have you improvised any algorithm, or you have used the as such techniques to do some experimentation?
Actually, sir, we didn't use the complete algorithm here, but instead we utilize some of the important components of that algorithm.
So you have not optimized anything, which means that you have used the as such algorithms. You have not optimized your own algorithm.
No, we didn't optimize the process.
Okay.
But we optimize within the environment. We applied that particular algorithm in different environment, and for that particular environment, we optimize the results.
Okay.
That's
and how you validated your results?
We have the standard frontier here, right? And we have ABC and IWO. These are algorithms, recently proposed algorithms, right? On these algorithms, other researchers also justify their results, right? So by applying the same configuration as they applied, we applied here, we configured here for these algorithms and we find the results on the efficient frontier, right? And we are very close towards the efficient frontier. However, we have multiple measures to find how close we are, right? So in this particular problem, we basically the most important thing is we didn't have a single way to measure that we have the optimal result. Right?
So my suggestion to you is that when you now want to improve your work, you just try to add your own optimizations. You take that is called the golden eagle as the base, but you try to optimize some of the variables. You try to optimize that. Like suppose we take ant colony optimization, but now the people have even gone for improvised, you've even gone for more optimized. Okay, so make that thing which is taking some base of improvised golden eagle algorithm, and even you should add 2 algorithms more that you should study. One is known as that is the dolphin accolation, which is also very important.
Okay.
And secondly, if you are talking of these type of mathematical problems like portfolio management, where lots of mathematics is involved, then we also recommend that you should also talk of dolphin accolation. You should take these algorithms and then try to compare the results. These will also give you better optimizations that how much your research is validated and how you can improvise that. Okay. Sure. And the second thing is, which is a suggestion for you when you come to the presentation, it is very important for you because you're working for proposed methodology. You need to cite, because it's a algorithm paper, it's swarm intelligence. You need to cite your algorithm. You need to cite your flowchart, which is very important. Because mathematics is okay, that is called system model, but the architecture and the algorithm and flowchart, that should be in front of us so that we can study that what exactly is the flow of the work proposed and how you have taken that as a base for these graphs. And second, and one more suggestion to you, that also put some tables and data values so that we can also validate that what kind of results are being extracted from MATLAB. Because only showing the graphs is not the enough cause. You should need to validate your data with tables also. This is my suggestion.
Sir, I show the table.
Yeah, okay. Oh, yes, okay. Okay, so, okay, that's okay. So you can work on these techniques and more optimizations. If any problem, you can contact me back.
Sure,
okay.
Sir. Thanks a lot, sir.
Thank you, thank you.
Thank you.
Coordinator, sir, we can have the next paper.
Yes, sir. Thank you, sir. Next, we have paper ID 347, Mr. Raghav Prasad. Mr. Raghav, yes.
Yes, sir. Yes, sir. Sir.
I'm making you the co-host. Now, please share your screen and start the presentation.
Host disabled participant in screen sharing.
No, try now. You are now the co-host. You can.
Screen share. Go. I'm going to go to a screen share, but host disabled participant.
Please check once again.
Okay. Yes, yes.
Mute the other participants and the participant, please start, please. Thank you.
Yes.
Screen, go to screen share.
Yes.
Visual, sir.
Yes, it is visible, sir. And please be limited on time, sir.
Okay. Thank you very much, sir, for your kindly suggestion. So, very good afternoon to all. all. So, myself, Dr. Raghav Prasad Parugha from Indira Gandhi National Tribal University, Amarkantak, and my paper ID is 327. And the title of this paper is Combined Heat and Power Dispatch by Boost Particle Swarm Optimization. So these are the some contents: introduction, classical PSO, and proposed methodology named as improved PSO, IPSO, simulation result analysis and conclusion. So these are the background. If we go for the basic particle swarm optimization, basic particle swarm optimization, then we can see that it is need for modification because it is very powerful, no doubt, for solving complex optimization problem, but it has some drawbacks like some advantage like easy implementation, fast convergence rate, but among these benefited, this is having some drawback also, premature convergence and diversity. So the main achievement of PSO, if we want to achieve new achievement of PSO, then we go for some parameter updation or some step updation like velocity and position update. In velocity, totally dependent on these parameters like acceleration coefficient and inertia bit. If we able to modify these parameters and some terms, then definitely we go the results comparison to others. So here I mentioned only 5 papers. Here first one is Rawat Veera ETL in 2004. Author proposed one PSO hybrid particle swarm optimization, which is based on time varying acceleration coefficient. Means this, the author presented some new parameters and implemented in velocity update equation, then that make good results. Similarly, Young ATL in 2007 presented dynamic PSO. It is also based on some novel parameters, and these novel parameters are based on velocity update equation implemented. Mendes et al. Novel PSO. In this novel PSO, the author modified the particle position update equation, means position update equation through additive of some terms. Similarly, the next author in 2014 proposed an FGLT PSO, which is global local best fuzzified particle swarm optimization. And the last one is Parova and Burma 2021. The presented one ADE and APSO, and the hybrid of these both two HADPSO then get me better result. So in this paper, we are generated some one new algorithm, a new PSO, and checked first in unconstant benchmark function using two benchmark Rastrigian and Rosenberg function, then applied in combined and heat economic load dispatch problem, which having 4 power units, 1 heat unit, and 2 cogeneration units. So the main objective of this paper is to minimize the total cost of fuel and emission through meeting the inequality and equality constraint plus load demand. So if we go for the basic PSO, then meaning of basic PSO, if we go for the like particles are flying, why they are flying, why they are, if fish are schooling, why they are schooling. So the simple thing, they are searching the food. They are searching the food means finding the solution. They are finding the solution. Finding the solution means searching the solution means find the solution for better and better. If we see that number of particles are moving around in the sky, but one word which is nearest in the food, the first one is known as global best and other one is known as particle best, means they are personal best. They are also improving, but one is very nearest. So these are some solution vectors in our space. So what is the many steps of PSO? First one is velocity update, and after initialization of vector, we are randomly generate the particle position and velocity. Then velocity updating by this formula. If you see this formula, then the V is equal to W into V. This one is the inertia vector, and V, this is the current velocity, which is controlling by inertia factor, and this is the cognitive component, P best minus current into C1 R1. Why this one is cognitive component? Because here particle improving its particle is means contacting itself, means personal best is also improved in cognitive, means this one is the cognitive because everyone is improved means yourself. Here next one is C2R2 into G best minus. Here this one is the social component because here every particles are every particles are contacting with one global best particle through the and getting the improvement. So this one is the social component, and the R1 and R2 are these two random number which is lie between 0 and 1, and C1 and C2 are the acceleration factor which is challenging, and this is the challenging which is between the, if we are changed, then the population experience may be working better and we get the good velocity update equation. Then step 3, we are go through the position update equation. Position update equation means previous position plus velocity, then we get the new position. This is also one question here to update the memory updating, how we get the update the P best and V best. According to the function value, we are, if the function value of previous one better is in next iteration, then we are updated Pi is equal to Pi best. Similarly for global best. And the last one is step with stopping condition. If you reach the optimal solution according to your stopping criteria like function evaluation or iteration, then you check accordingly and report the optimal result. Report the optimal result means you go for, you check your function value. So this is the very crucial condition right now in particles or in every algorithm, how to choose the parameter, because parameter is very influenced all the steps of any algorithm. So we are design here an improved particle swarm optimization. In this improved particle swarm optimization, we design C1 and C2. Here, if we go this formula, then C1 is gradually decreasing and
Hello, Mr. Raghav.
I think his connection is lost, sir.
Yes, sir.
I think connection is lost.
We can wait for him for 1 minute. Otherwise,
Yes,
we can
sir.
start the second
Yes.
one.
Yes.
Third one, sir.
Yes.
hello.
Yes, Raghav. Please share your screen.
Okay. Sorry
Yes.
for due to
No
some-
issue, sir. Please try to summarize the things because we are running short of time. Please try
Okay. So we are generated these two new formula. These two new formulas C1 and C2 were acceleration coefficient for cognitive and social component, and also some inertia weight. This inertia weight is, if you see, also decreasing, which is maintaining the velocity in a better way and improve the velocity to obtain the global optimal solution. We check this. If we put in this in the velocity update formula, then we get new velocity update formula and check this swappable function. One local optimum in between minus a global optimum in minus 50 to 50, and these are the some objective function and bounds between minus 500 to 500, and the minimum is minus 420 minus 420.9687 based on dimension. So we check in a 100 dimension. Here is the global. If you see here, this is the global optimum. Then this is the initial vector, and after 5 generation, after all we are checked this one, all particles after 350 generation moved to global optimum. This is the better quality, and some result are discussion. We are compared this algorithm through basic DE, basic PSO, and one hybrid version of PSO DE. This is the hybrid last one, and this is the improved version of particle swarm optimization IPS in our proposed algorithm. So we think, or we are got better result to comparison to others. And this is the some graphical representation, convergence graph. We are converge means taking one initial population, seed population, then coded all algorithms and the run through the same population. Then we see that here if we see that here the IPSO may be in between objective function value and iteration, the IPSO may convert very less iteration. So this is the for the next function, and we are check in the result and discussion with the combined economic dose for power unit, 2 heat unit, and 1 co-organization unit. Total power we get, and the heat may be loss is also better. So the conclusion for this one is improved factor. These are decreasing because this is the based on increasing or decreasing parameter. So W decreases gradually, which maintain global and local exploitation ability. Suggested C1 and C2 decreased and increased respectively, which is improved global search competency. So initially, if we see initially C1 increases and C2 decreases, it pushes elements to passes in whole solution exploration, whereas C1 decreases and C2 increases, then it twisted to the inclusive solution, means exploitation. As per the graphical solution, we can say that these parameters working better in the if we are implemented in velocity update equation and get a good result. So thank you very much. If you have any question, please.
Thank you, sir.
Raghav,
Yes, sir.
actually, this is very basic question. Basically, there are 2 optimization algorithms.
Yes,
one is
sir.
genetic algorithm and second one is PSO. Suppose.
PSO.
Why are you using PSO, not using genetic?
Sir, actually, genetic algorithm we are studied, but better with when we are executed some result, then this much is computationally better and easy to implementation, sir.
No, this is not a correct answer.
This is because both are population based techniques, sir. Number of parameter is there in GA. Binary coding is needed, binary coded genetic algorithm, number of
How you mapping? I think you use IPSO, no?
IPSO, yes, sir.
IPSO. I means
Improved PSO,
improved. Okay. So how you mapping with your problem?
Hello.
How you mapping PSO with your problem?
Problem is based on some we are getting the states, sir. Then we are initialized because there some objective function is there, sir.
Then how you mapping?
Mapping means, sir,
आप अपने मैपिंग कैसे कर रहे हैं? प्रॉब्लम को आपके पीएसओ को प्रॉब्लम के साथ कैसे मैपिंग कर रहे हैं? आपका जो बेसिकली
because this one is when we are generated randomly one population, sir. According to the problem, where they are based on the some objective function and constant. So we are generated this one population through the problem, sir.
No. Which witness function you are use?
In Swaffle and Rust region, sir. Basic function. This one.
Raghav sir?
Ji, sir.
Okay, Anand sir.
Yeah, thank you for the presentation. But actually, already Dr. Jatendra has already asked my question, which was my first question to you, that why you are not using a genetic algorithm, because actually, if you're talking of these things, then genetic algorithm is one of the optimized approach. We cannot say that it is easy, but actually it is optimized, but you must try to find more research, then only you will be able to elaborate the answer. Okay?
Yes.
Now, my question to you is that what is the future scope? First of all, what are your next steps for by taking this as the base research for you?
Sir, my next step is when I am checking this is in benchmark for validation.
आप हिंदी में जवाब दे सकते हैं. I know Hindi. आप हिंदी में जवाब दे सकते हैं.
Yes, sir. Sir, actually we are means testing this function, testing this generated algorithm in
what kind of testing for
validation, sir, on constant benchmark.
But the main thing is validation is not the answer. Suppose you have to case study, and then suppose if you want to apply this approach for some sensor communications or for some optimization.
Yes, sir. So
So tell us that area, na, that what you want to apply, how you will validate. That's all.
We are validated through some electrical engineering problems,
But what kind of problem?
like economic load dispatch problems.
Oh, yeah, that is the answer. Of course. Okay, say in a broad manner that what problem, because let me tell you, swarm intelligence is actually made to solve the problems. That's why it is called optimization problem. And that's why we are using the nature-based algorithms in order to solve the problems which are not being able to use. That's why it is called NP hard problems.
Yes,
Okay,
sir.
that's why they are meta heuristics. Okay. Now, my another question to you is that, but what I observed from the results, these results are very basic. So don't you think
Yes.
that right now this research is not enough for presentation like all
Yes,
this?
sir. Yes, sir. Yes, sir. Yes, sir. Really true.
Yeah, actually, frankly speaking, I'm okay with your paper, that your research okay, but it is not well enough, you can say.
Yes, sir.
It's not complete in itself.
Yes, sir. Yes, sir. Yes.
Yeah.
Because we are putting only 2 basic benchmark in some.
Yeah. Because 2 benchmarks is like a work of only 15 days that you can do in that.
Yes, yes, sir. Yes, sir. No doubt.
Okay. Okay, thank you. All the best for research. But next time when you publish the paper,
Yes.
make it very clear, and you can say that. And one more thing, you please don't work on these things like PSO. What is that PSO? We all know about PSO. So focus,
Yes,
if
sir.
you are presenting the paper, focus on your proposed work only. Okay. We are here to listen to your proposed work, not to the literature. Actually.
Yes.
Okay. Thank you, sir. Thank you. Thank you.
Anyone?
Excuse me, coordinator, sir. I want to say something to the participants. May I have the permission to say, please?
Yes, sir. Please, please.
Participants, please focus some little information or stress on your introduction. You can skip the literature. Don't stress on the related works. Just come to your proposed work only. What is your proposed work? Experimentation. And if there is a case study, elaborate that. Skip the literature review and more broad of introduction. We are not interested for much of that. Okay, so please focus on that, please. Sir, we can call with the next paper. Yeah.
Yes, sir. Thank you, sir. Next paper is 129, Mr. Sri Ganesh.
Yes, sir.
Sri Ganesh Yadav. Yes, I'm making you the co-host.
I think
sir.
his paper is done, portfolio management. I think.
It was Mr. Faraz, sir. I took a paper ID 129, but took a name of another presenter.
Yeah,
That's
yeah,
my
Mr.
mistake.
Farhad. Then it must be hybrid moth search and
Yes.
dragonfly. Yeah. That's why I got confused.
Yes, sir.
It's okay.
Sorry for the
Please-
inconvenience.
It's okay. Please move ahead.
May I, sir?
Yes, sir. Now you
Please,
can
please
share.
start the presentation. And sir, please focus on your proposed work and just play little stress on your introduction and literature view. If it is better, you skip the literature view, please.
Sure,
Thank you.
sir. I will definitely take care of that. Good afternoon, one and all. My name is Sri Ganesh Yadav and I'm presenting today's paper. My title of the paper is Hybrid Moth Search and Dragonfly Algorithm for Energy Efficient 5G. So table of content, which we all know that we have this kind of table of content: background, literature survey, problem description, methodology, research discussion, and conclusion. So basically, my background is today we are really interested to go for a 5th generation 5G mobile networking, which was first deployed in year of 2020. The 5G network performance needs to satisfy the quality of service. Basically, quality of service contains the packet loss, jitter, latency, and bandwidth. The 5G network should have a higher data rate, low latency, and large bandwidth. In 5G network, device-to-device communication give the ability to reduce the power utilization. On other hand, D2D, that the device-to-device communication in 5G network, introduce new technical challenges, which includes mode of selection, resource allocation, power allotment. We proposed an optimal power allotment model, which directly guarantees the energy efficiency of 5G network while assuring the quality of service. We propose the hybrid moth search and Dragonfly algorithm, that is combined advantage of both moth search algorithm and Dragonfly. Here I will little bit say about this Dragonfly algorithm and moth search. Here the 2 diagrams are there. The first one is a moth search algorithm, where we are actually using its natural tendency to follow the light, inspired by this natural tendency to follow the tendency to new kind of algorithm moth. And second one diagram is related with the dragonfly. This algorithm is originate from the statics and dynamic swarming behavior of dragonfly in nature. These two essential phases of optimization of exploration and exploitation are designed by modeling the social interaction of dragonflies in navigating navigating and avoiding the enemies like this. This is a literature survey. Actually, we are really interested in what is my problem description. So here my problem description is to make the 5G network more energy efficient while maintaining the quality of service. How to use a nature inspired optimization algorithm to make 5G network more energy efficient and to maintain the signal noise ratio while reducing the power consumption. Methodology I have mentioned there little bit here. Actually, this is my proposed 5G network architecture where I will try to focus more on my energy efficient network, where I will use this MSA and DA algorithm, where it will give me a great power less power allocation and great power efficiency. So this is the basic 5G network architecture. A base station is a central communication model that contains large network, several sub-network, piconet, femtonet, micronet, and each contain their own local base station as a formed around. Now I will come to the result and discussion. Here the graph which I mentioned in the presentation is a cost function versus iteration. So here it is a great for us. That means basically in the diagram, as per the iteration, how the different algorithm perform with respect to different cost function. So there are 4 cases. One is ABC, that artificial bee colony. Second one is a moth search algorithm. Third one is a dragonfly, and fourth one is which we are proposing, that moth search and dragonfly. So we can see that where roughly around 15 to 16 iteration onwards, energy cost function has reached to its saturation value, and the minima was found out to be MSA-DA combination, which is our proposed algorithm, as compared to the individual one, that is ABC, MSA, and DA. Well, now I will little bit talk about ABC. ABC is nothing but artificial bee colony based on the meta-heuristic algorithm that was introduced in 2005, inspired by the intelligent foraging behavior of honeybees. And this is nothing but actually, if you implement 2 network systems, so one device switch to another base station, slowly that device try to make their own small network over there. And this is another graph which we found at the time of this paper. This result discussion, the first one is nothing but bandwidth and number of users. As number of users are increasing, bandwidth requirement in Mbps is also increasing for all MSA-DA and MSA-DA, which is obvious that, but MSA-DA still have a lots of free bandwidth, because it is just consuming, if you see that it's just consuming around 30 Mbps for around 500 users. So whereas almost 20% to 60% is saving happening on the bandwidth. Here we are basically interested in that if the number of users increase, then there should be minimum the consumption of band. If it is not, then MSA-DR are usually better than MSA-DA, which is my proposed algorithm. So we are actually looking for bandwidth utilization of optimization. Again, the second one is the fitness and interaction graph, where MSA-DA, MSA and DA both performs eventually well on higher iteration side, but initially fitness value of MSA-DA was lower, and that's why we can say that the number of user increases, the fitness value improves for our proposed algorithm. It doesn't go down. So my conclusion here is we have developed, means we are trying to develop the nature-based optimization power allocation scheme that increases EP, energy power efficiency, and ensure the quality of service over multiple input, multiple output oriented 5G network. We propose the MSDA scheme, which is at SNR minus 20 dB, achieve an efficient value around 16 bits per joule, and at least 4 times better than the existing algorithm. MSDA performs well even with the single antenna. This proposed MSDA method can achieve fitness of 30 even with the one antenna, and MSDA has achieved least cost function, proving to be one of the most efficient algorithm for optimized power allocation. These are the reference. Thank you so much.
Thank you, Mr. Shrigan. Sir.
Thank you, sir.
Okay, Mr. Yadav.
Yes, sir.
Actually, I don't understanding what is your contribution in this work?
Sir, basically what we are trying to do that we are actually mixing the basic component we are actually taking from that individual MSA algorithm and DA algorithm, and we are actually using these two and combining it together. As I show in this result and discussion, which I not share all the graph here, but basically individually and combining this MSDA are giving me a better result while saying as compared to the individual one. So basically my work is to combine these two algorithms and make it more efficient another one. So I'm not making any algorithm, but I'm actually improving my result to get the power allocations, efficient power allocation.
Right. Okay, Anand sir.
Yes, actually, if I start talking regarding the questions, maybe it can take 2 days because this is my main area of specialization.
Yes.
So, sir, actually, frankly speaking,
Yes,
actually, I'm not impressed with the paper. Actually, I'm not impressed with the paper. Actually, the way of presentation and of course the things that needs to be presented were actually missing. So the first thing I would like to first of all speak that what was missing. If you are making two algorithms, even as a combined approach, you mean that you are actually deriving a new algorithm. Naturally, because this is algorithm 1, this is algorithm 2. And if you combine together, it doesn't mean that you just add these things. You have to optimize them. You have to make sure that the variables are set properly. And then you have to come with the mathematical expressions that is called system model. And then you have to go for that. Even if you apply the combined approach, algorithm has to be there.
Yes, sir.
Yes or no?
Yes, sir. Yes, sir. I'm totally agree with that.
So how you can say that you are not designing an algorithm, and how can you say that you are not designing the algorithm, but you are optimizing the results? How can you do that? Yeah. This is the first time I'm listening in my career of swarm intelligence of 10 years. How can you not make an algorithm, and how can you optimize the results? This is actually a wrong statement, according to me.
Sir. Yeah.
Now coming to you, sir. Now, this is my question to you. Now, listen to me very carefully. Now, maybe it will be disappointing for you, but actually it is a fact. You should understand. 5G networks are already energy optimized.
Yeah.
You understand, sir? Because why I know about 5G, let me tell you about my background. Da Nang is a smart city. It is the number 10 city in the world, which is in smart technology. Number 10. And over here we have 5G. Even my iPhone right now is using 5G. Yes. We are using 5G, and in 5G, energy is not a problem. We can see that there is no major battery drop, but we see there is a problem of QoS, and that is the area where we are working. And in that area, we are focusing our research and our optimizations.
Yes.
Okay. So what I can observe now coming to your results. Now, can you come to the next slide, please? Results. Next slide. Now, what is missing? Now, this is another area which is actually out of way that you should explain. Now, you say bandwidth. Now, what kind of bandwidth you are talking? Like, suppose if I'm a user of 5G, what type of bandwidth? Like, if I'm streaming a 5G, if I'm streaming a 4K movie, or if I'm going to YouTube, what kind of traffic you are optimizing? This is again missing. Now, what is that? This is my question to you, first of all. What kind of traffic you are actually asserting?
So that I'm actually expecting the bandwidth in this video calling and watching videos. And
you should mention that what kind of bandwidth. That is what I'm saying. You, because you just say bandwidth, but you must understand that there is a case study. You have to take a case study in that area.
Yeah, sure, sir.
Yeah, but your case study was not there. That's why I'm asking the questions to you, that what kind of bandwidth you are actually monitoring. Now, my another question, now watch carefully what I'm going to ask you. How many users per region? We say that 5G is like a femtocells like that.
Yes, sir.
So how many users have you taken as a base? And what was the primary and the obvious bandwidth that you have taken, and then you have applied your technique?
I think
Now, this is your question. You said that you're optimizing the results. Okay,
Yes,
5G
yes,
is
yes.
already optimized. Now, this is my question. How many users in that region and what was the primary bandwidth? Then you applied your algorithm and then how much was the bandwidth? This is my question. We can talk whole day on this. This is my area. I work practically on this area with the government.
Yes, sir. Yes, sir.
So you must find these problems. Because
Yes,
this is
sir.
not MATLAB, we have to find these things, that what was your basic, that is called assumptions that you have taken. Okay. And rather than you focus on energy, and
Yes,
let me tell you, your Dragonfly algorithm is not working for energy. We have
Yes,
even taken this as a base for wireless sensor network, but we didn't get any optimized results. Any optimized, we don't get. That's why we are coming towards like a spider monkey algorithm. We are coming towards a glow worms algorithms that we are using in that. So my recommendation to you is that you just focus on quality of service. Actually, your bandwidth. Actually, you are talking of energy, but in bandwidth and in iteration, you are talking of quality of service.
Okay.
Yeah. So actually, that's the reason I'm saying you that I was not impressed with your paper. Actually, I didn't get that particular shape. You need to find out the algorithm. And of course, you need to have the flow chart that how your algorithm is actually flowing. What was the assumptions and what were the primary network parameters you have studied, and then you have applied the optimizations.
Sure, sir.
Okay.
I will definitely
work on that. And if you need help, you just call me back or email me. I will help you on that. Because we work practically in this area.
Sure, sir. I will, sir. I'm ready. Thank you so much for.
But don't be demotivated. But don't be demotivated unless I don't give you the critical that is called criticism. Then you will not understand that what is the drawback and why we are here. Because we need to understand what we are right and where we are wrong. Okay, so that you can work. Okay, so focus on quality of service with that.
Sure, okay. I will take it in a positive way, sir. Definitely.
Yeah. That should be the spirit. Okay.
Thank you, sir. Thank you so much.
Yes, I have one question.
Yes, sir.
Yes, I agree with the Professor Anand, and see the combining the two things and they saying it is the efficient. That is not it should be justified. Okay, so you have not included the theoretical analysis of the proposed algorithm. The empirical analysis that is not going to work. Okay, unless you are going to analyze the and the theoretical analysis it is done. Okay,
sure.
So that part it is missing.
Sure.
Over from my
actually,
side.
that was my actually, Mr. Uday, I wanted to ask him many questions, but due to time frame, we have to cut down. But actually, I can take this discussion for 2 days also.
Yes.
Sure, sir. Thank you so much.
So we can take the next. We can take the next participant.
Yes, sir. Thank you, sir. Thank you, Mr. Shri Ganesh. You are really lucky from our session chairs. And thank you, session chairs. I'll proceed to next paper. That is paper ID 160, Mr. Raja Lakshmi. Yes.
Sir, the participant should stop sharing the screen, I can see.
Yes. Mr. Shri Ganesh, please stop
please
sharing.
Mute the participants, please. Mute the participants. We are getting disturbance.
Sir, am I audible?
Yes, now you can share your screen, Ms. Raja Lakshmi.
1 second.
Rahul?
Yes, sir.
Also ask presenters to on your video also during presentation.
Yes, sir.
If they don't have any problem, but if you have network problem, then it's okay. But if don't have any problem, then please ask them to on their video also.
Yes, I request all the presenters to switch on their video while presenting.
One second, sir. On my video, sir.
It is showing that you have started the screen sharing.
No, first start your presentation. If you are facing any problem, switch on your video. Then it is not mandatory, but it is
Yes, it is
now you are visible. Now start your presentation, ma'am.
Yes.
Yes, Raja Lakshmi ma'am, please, Thank you.
Yes. Good afternoon to one and all present here. First of all,
Ma'am,
thank
your screen is not yet
The
visible.
screen is not visible. Please share the screen.
1 second. Is it okay, sir? Is it visible now, sir?
Yes, yes.
Thank you, sir. Good afternoon to one and all present here. Thank you for giving the opportunity. Myself, Rajalakshmi. I'm going to present a paper titled Prediction of Dementia using Van Optimization Algorithm Based Convolutional Neural Network. This is the agenda of my today's talk. Dementia, which is a chronic disorder that affects the mental health of the person. It causes problems in memory disorder, affects thinking abilities of a person, and also it affects the day-to-day life activities. There is no such treatment that cures the dementia fully. That has to be predicted before the occurrence of the dementia. So we intend to detect the dementia using convolutional neural network. Van optimization algorithm, a meta-heuristic algorithm which is used to tune the hyperparameters such as mini batch size and dropout rate. In particular, we had taken AlexNet architecture. In that, we had fine-tuned the parameters such as mini batch size and dropout rate in order to increase the performance of the convolutional neural network in order to optimally predict the occurrence of dementia. So these are some of the existing related works in which they had diagnosed the Alzheimer's disease by using the voice recordings, by using additive logistic regression with an accuracy of 86.5%, and normal conversational speech has been detected using voice activity. The dementia has been detected with a recall of about 0.645, and canonical particles from optimization based convolutional neural network has been designed to fine tune the hyperparameters of CNN. The main problem that we have taken here is that the hyperparameters in CNN are essentially numeric values. Thus finding the optimal value is really a NP-hard problem, and thus requires any approximation algorithms or meta-heuristic algorithms as a solution. Also, the hyperparameters like a dropout rate and batch size plays a crucial role in the convergence of CNN with a better accuracy. Since accuracy is a prime concern not only in the medical field, but here we had taken dementia, which is a severe healthcare problem. That has been solved by using the optimal convolutional neural network, where the parameter, the optimal in the sense, the hyperparameters of the CNN are fine-tuned by using the proposed Van optimization based algorithm, so that the algorithm achieves very good accuracy with the minimum loss. So this is the schematic architecture of the proposed system, where we are having where we had used AlexNet architecture. In this, we are having 8 layers, out of which 5 layers are convolutional layers and 3 layers are fully connected layers. The hyperparameters play a prominent role in the convergence of AlexNet. So there are so many hyperparameters, including filter size, values of the filters, weights in the fully connected layer, dropout rate, and mini batch size. In this paper, we had taken 2 hyperparameters, say dropout rate and mini batch size, for fine-tuning the convolutional neural network in order to prevent the model from overfitting, and also to boost the accuracy with the minimum loss. We had find the values for dropout rate and batch size, and then the model has been trained to optimally predict the occurrence of dementia. The input data set has been taken from the Kaggle, where the dimension of the data set is 227 cross 227 cross 1. So this is a schematic algorithm that we had used to find the hyperparameters of a proposed val optimization based CNN. So here a number of our vals that we had taken into account is 20, and number of iterations we had taken it is for 100, and the output that given by this val optimization based algorithm is mini batch size and a dropout rate. So for each iteration, the algorithm intends to compute the fitness. The fitness we had taken is accuracy of the CNN, and also at each iteration, the algorithm carefully do the proper exploration and exploitation in order to carefully find the optimal values for mini batch size and dropout rate. So the mini batch size and dropout rate can be found by using the best val position and also the random val position. So these are the details of the data set. So we had taken a dementia data set from the Kaggle repository where the number of instances that have no dementia is 2,560. So we had given a ratio of 70:30. So it has been split into 1,792 for training and 768 for test set. Similarly, for the mild dementia, very mild dementia, moderate dementia, we are having the equivalent training set and test set. And we had compared our proposed WOA based CNN with the conventional CNN architecture. So first of all, we had monitored the values of accuracy for the dropout rate. So for each dropout rate, we had monitored the accuracy. So if we observe that the value of the dropout rate is 0.8, the accuracy of the val optimization based convolutional neural network is 98.987%. Also, when the dropout rate becomes 0.9, the accuracy is actually decreased by 1.99%. So here the val optimization also, when the dropout rate is considered to be 1, that is all the instances were considered. In that case also the accuracy is considered to be 97.011%. So which is actually nearly the same as for dropout rate of 0.9. So from the dropout rate from 0.7 to 0.8, actually the accuracy gets improved by 1.58%. So the next we had measured the accuracy for various mini batch sizes, say for example 100, 200 and 400, and it is found that when the mini batch size is set as 100, the accuracy of the proposed WOA based CNN is given as 98.987%. So the having found the dropout rate and mini batch size by the convolutional neural by the val optimization based algorithm, the accuracy at each epoch is monitored. So the accuracy for the proposed val optimization based CNN and the conventional CNN has been given. It is found that the proposed val optimization based CNN achieves a 3.46% greater accuracy than the convolutional neural network. The reason for increase in the accuracy is because of the dropout rate and mini batch size, which is determined using val optimization algorithm in the proposed AlexNet architecture, whereas in the case of CNN that is taken randomly. And the next level of comparison is done based on the loss value. So if you see the loss value at the epoch 15, actually there is a decrease in the loss value from 1.679% to 0.673% in WOA CNN. Also, there exists a gradual decrease in the loss value, and also further the proposed WOA based CNN is having 2.16% less than the conventional neural network architecture. Finally, we conclude that the essential of predicting the dementia is in advance studied since the once the dementia occurred, it cannot be curable. So here the val optimization algorithm based convolutional neural network had been experimented to predict the dementia in advance. Also, the val optimization algorithm is integrated in order to prevent the model from overfitting, which actually degrades the performance of the model. So the proposed algorithm has been experimented with the dementia dataset that is taken from the Kaggle, and the proposed WOA based CNN actually achieves loss of 0.04%, which is 2.16% less than the conventional AlexNet architecture. These are some of the references. Thank you.
Rajalakshmi, basically with CNN, you are using WOA, no?
Yes, sir. Val
optimization algorithm.
Yes,
so there are so many optimization algorithms are available.
Yes, sir.
So what are you? Why you are choosing WOA?
Sir, actually, it does a great level of exploration and exploitation. It is switching in between the exploration and exploitation in the probability value. So, in order to promote both exploration and exploitation to have a better accuracy rate, we are going for this. And also, we are experimenting with sine cosine algorithm and particle swarm optimization algorithm, sir. So this is as part of a journal paper. We had put it as a conference paper, sir.
Which two optimization algorithm you study?
Sir,
val
optimization algorithm we had actually tried, sir.
Okay, right.
Just any more queries?
So Rajalakshmi ma'am, let us have some discussion now. So ma'am, first of all, go to the data set. Hello.
Yes, sir. Yes, sir.
Yeah, madam, can you hear me? Yeah.
Yes, sir.
Yeah. So ma'am, I want to ask you that what is the percentage that you have taken of the data set for training and how much percentage for results and validation?
Sir, it has been taken as 70:20, sir. Sorry, 70:30.
70:30.
Yes, sir.
30. But
Yes.
do you think that 70:30 is the perfect presentation for applying the swarm intelligence, because you have to take many assumptions then?
Yes, sir. Yeah. And I had actually referred so many journal papers. So based on that, I had taken it as 70:30, sir. Anyhow, I will be trying for 80:20 and 90:10 also, sir, in future.
80:20 is the perfect ratio rather than to go for 70:30. Okay.
Sir. Sure, sir.
Now let's talk to your methodology. Can you go above the slide? Okay. Now, can you explain me this formula under number 6 and number 7, how you derived it? Hello? Hello?
Hello, Mr.
Madam, can you hear me?
Rajalakshmi?
Hello?
I think some connection issues.
Okay, no issue, sir.
I think we have to wait for some seconds now.
Yes, sir.
Okay, no issue, sir. We can start with the last presentation. No problem.
Yes, sir. Yes, sir.
Actually, there were some good questions for her, but anyways, it's bad luck. Okay, we can continue with the last paper, sir.
Yes, sir. Thank you, sir. The last one is 189, will be presented by Mr. Faraj Hassan. Mr. Faraj?
Yes, good afternoon, sir.
Yes. I'm making you the co-host. Yeah.
Sorry,
Now,
sir. Sorry, sir. Sir, shall I share my screen now? Extremely sorry, sir, for the inconvenience.
It's okay. Now we can start with the last presentation.
okay. Okay. No issue.
It's okay,
Thank you.
ma'am.
Shall I start?
Yes, Mr.
Mr. Farhas, please focus on the contributions only. Thank you.
Sure.
Thank you. And your proposed work only. I think this is the second paper. I think it is also collaborated with like the first paper also.
Yes, sir.
Yes, sir.
He is the co-author, Mr.
I'm the
Faraj.
co-author of this particular.
Okay, we can go for only like a system model, problem description, experimentation, and your proposed work. You can
Sure.
skip it.
Okay, so I will start from the problem description first. In this particular paper, we applied our the problem with the Sharpe ratio model, right? Instead of the weighted mean model, we applied here the Sharpe ratio, right? And the main problem with the Sharpe ratio is we have to optimize the average return divided by the total risk, right? So we have this particular Sharpe ratio. Now our problem is become maximization problem, and the risk is here is being modeled as a square root of or summation I ranging from 1 to n, summation j ranging from 1 to n, wi, wj, and cv, ij, where cv is again the covariance in between I and j, right? And we have the Sharpe ratio as, now the objective function is the Sharpe ratio, and the maximization of this summation I range 1 to n ri into wi. This is the expected return divided by the risk. Right? Now the subject to constraints are the same as in the previous paper. summation I is equals to 1 to n, wi is 1, the sum of all the weights is 1, weights, each individual weight is greater than 0, and the weight lying in between A and B. Now, in this particular paper, we use the penalty function also to optimize or to apply the constraints, right? So if the algorithm goes in the wrong direction, we have to give the penalty to that particular bit. So we have the penalty function jx is equals to f plus summation gix if x didn't belongs to the x, right? And fx itself if x belongs to x. So this is the problem description that we have. Now, the methodology we use here, we applied the gray wolf optimization here. And why we use the gray wolf optimization for this particular problem is the characteristics or the processes that the gray wolf have during the hunting process. So important characteristics of gray wolf is its social hierarchy. It establishes the social hierarchy. It's the tracking prey. He can easily track because the wolf attacks always in a group, right? So it creates a social hierarchy around the prey. It can easily track the prey, and the group of wolves can encircle the prey, and then the leader of the wolf can attack on the prey. So attacking prey. So all these are the 4 different processes for gray wolf. So by taking these or by motivating with these social processes, we apply the gray wolf optimization for optimizing the Sharpe ratio. So social hierarchy here, in general, we have basically 4 different categories of wolf in social hierarchies: the alpha, beta, delta, and omega, right? But in our approach, we are using 5. So alpha, beta, delta, and omega, and gamma. According to the hierarchies, alpha is the most fittest individuals or the leader of the wolves. Beta is second most fittest wolves who can be able to track the prey. Delta is the third most, and omega is the 4th most fittest wolves out of all the wolves. And the remaining wolves are the followers, and they are represented with the gamma wolves. So for encircling prey, we modeled, this is the mathematical model for encircling behavior of the gray wolves. So D is equals to C into XP, where P is representing the position of the prey minus the XG. X is representing the position of the group, the wolves. And we increment the position accordingly. XG plus 1 is equals to XPG, the current position of the prey, minus A dot D, where A and C are the coefficient vectors represented with A is equals to 2A dot R1, the radius, minus A. And C is twice of R2, where R1 and R2 are the random variables. Here we have the hunting behavior of the gray wolves, which is being represented with the equations. D alpha is C1 into X alpha minus X. D beta is C2 dot X beta minus X. D delta is C2 dot X delta minus X. D omega is C4 dot X omega minus X. And X1 is X alpha minus A1 into D alpha. X2 is X beta minus A2 D beta. X3 is X delta minus A3 D delta. And X4 is X omega minus A4 D omega. So these are the positions. According to these positions, we can find the average of these, and xg plus 1 is x1 plus x2 plus x3 plus x4 divided by 4. This is the mean of all these 4 locations. This is the hunting behavior, and here we have, sir, I added the suggestions of Anand sir. I added in this particular presentation the GW algorithm. So initially, in the input, we initialize the gray wolf population, small a, capital A, and C. Right. In the second step, we evaluate the fitness functions for the Sharpe ratio. Right? Third, we find the 4 best leaders. The hierarchy, we can construct the hierarchy of the groups from the population. And now, until the stopping condition is being there, right? We iterate through this particular process. For each point in population, we update by using the equation 10. So we update the position of the praise by using equation 10. Then we update the vectors A, capital A and C accordingly, and again calculate the fitness functions for each best individuals and update the generation by 1, G is equals to G plus 1. And at the end, we are getting the global optimal solution. Now, the result in discussions, the common parameters we use here for initial population is 100 and the iteration number is 100. This is the common parameters. Now, GA, we use GA to compare with our GW algorithm. So A is equals to 2 to 0. Number of leaders is now 4. And the fifth one are the followers. GA, we use single point crossover probabilities 0.7 and polynomial mutation probability is 0.3. By using these results, here we have on the left side, we have the convergence curve for respective GA and GWA, and on the right hand side, we have the execution time of GA and GWA, and both we can be able to easily see that the GWA is outperforming the GA for optimizing the Sharpe ratio in both in terms of execution time and the optimized Sharpe ratio. Here we have the tabular data for the analysis, right? So GA is 1 to 10 on the left and 11 to 20. So 20 different values we are representing here, and the average best and worst value we are displaying at the bottom. So GA is getting 0.399 while proposed GWO method is getting 0.40. So we are seeing here all the values are improved in GWO while GA have lesser values. So in conclusion, we can see the main objective of this particular paper is to optimize the Sharpe ratio of the constructed portfolios by applying the GWO in the environment of the constraint portfolios, as well as we are utilizing the penalty function over here. And an approach of parameter-free penalties was used to control the various constraints of the portfolios. And finally, by showing the results, we can be able to depict that our algorithm, GW-based algorithm, is performing well for both in terms of execution time as well as the optimizing results. Any questions, sir?
Thank you, Dr. Farah. Any queries, sir?
Jitendra, sir, if any.
I don't have any question.
Okay.
So thank you, Farhad, sir. This is called presentation, and actually I'm really impressed with how now the presentation was looking good. This is how we have
Thanks a lot, sir.
Paper. This is how we have to present the SWAM paper. Okay. So just work on the future scope. Okay. And
sure, sir.
It is better to elaborate the data from Bombay Stock Exchange to NASDAQ also. Let us try that you can find. Even you can find some more fluctuations from KOSPI. Okay. Hang Seng. Try to find.
Yes, I am working on Hang Seng.
Yeah, Hang Seng is the better area for you. So if you need any more data help over here, you can let me know. And even you can try more on the, you can take some help from cryptocurrency or cryptocurrencycharts.com and try to elaborate some of the data towards Ethereum and Hyperledger, some Ripple, take that currency and try to implement your methodology, how we can add optimization techniques for prediction in cryptocurrency also. That is the major area that I'm looking for. Okay, so try for other stock exchange and even for cryptocurrencies with the
Sure, sir.
you will get good results. Okay.
Okay. Thanks a lot, sir.
Thank you. Thank you.
Thank you, all the session chairs and presenters. On behalf of NIT Raipur and organizing committee of the conference, I thank you all for sparing I thank you all the session chairs and presenters for sparing very valuable time as well as providing valuable insights to the authors. It is kindly requested to all the session chairs to fill the evaluation sheet so that the best paper award can be decided and finalized.
Yes.
Thank you, sir. Thank you very much.
Thank you.
Thank
Thank
you.
you.
Thank you,
Thank you,
Dr.
sir. Thank
Anand
you.
Nair.
Hi,
Yeah,
Dilip sir.
Rahul, group photo हो गया? Hello.
हाँ सर, स्टार्टिंग में हुआ था, अभी we
ठीक
can have one more.
Jiten sir, thank you very much. Uday sir.
Yes,
Thank you,
sir.
Dilip sir.
Thank you very much. Thanks for your invitation.
Yeah, it's nice to see you all of, but it became more better if we can meet physically.
Correct.
So things are improving slowly, and hopefully we'll meet very soon.
So next could be the offline mode.
Yeah. Next could be not in 2022, but maybe in 2023.
Okay.
Because we have invested a lot of time in this conference.
And I would like to invite all of you at NIT Surat also, Gujarat.
Okay.
You can have the visit of Gujarat.
And I would like all of you to please come to Vietnam, be my guest,
Yes.
see our
Sure.
lab, see our labs, see our the research center where I'm the chairman. Okay, so please see there.
Sure.
Okay, sir. Thank you.
Thank you very much. Thank you, everybody, all presenters. Thank you.
Okay,
Thank you,
bye.
Thank you,
Rahul.
sir. Thank you, sir.
Bye.
Okay, bye.
Bye.
Bye.